There's nothing better on a Monday morning than a massive capacitor. You know what I mean? Alrighty, we're powering up the bike generator. We have got a big juicy capacitor, a 1 farad capacitor. It's actually a car audio capacitor, what it's designed for. It's a full farad, which is fairly standard for car audio capacitors, but it's a big old capacitor. It's got a serious amount of punch. New battery, just because the old one's knackered, so we need a new battery on there. This is it's a 7 amp hour battery. So what this means is we're going to be able to charge this up and then charge other things from it. The other one's just a 4 amp hour and it's pretty weedy at that. So this is a little bit better. Got a new voltmeter, that's going to go on the dashboard. So it just lets us know what's going on. At the minute the voltmeter's at the back. So this is going to let us know what's going on while we're riding. New switch, just because the other one's broken. And I've got a new ignition switch for the field coil. At the moment the field coil is on a push to make, push to brake switch, which is irritating because you can just forget that it's on. Whereas this one, momentary switch, so we just press it and we ignite. It will all become clear when we get to the generator. Now, the reason I'm putting a capacitor in, I didn't have a capacitor in the circuit before. The reason I'm putting one in now is because we've got some projects coming up, some fun projects with the bike generator, which need a big momentary current draw. And the problem with that when you're pedaling, if you've only got the alternator attached, is it locks up. It locks up, so it becomes immediately very, very difficult to pedal, so you tend to stop. And a battery, it can damage a battery if you try and draw too much off a battery. So this is a 7 amp hour battery. If you momentarily try and draw 20 amps off it, it doesn't do anybody any good. So capacitor is what you need for that. It smooths out. So the alternator has rectification built into it, but you still get a slightly dirty DC signal. This smooths it out, makes it nice and clean. You don't need a capacitor this size to do that. You could get away with a much smaller capacitor. But you know, go big or go home. That's what I say. So we're going to test it. First of all, charge it up, test it, make sure it's working all right. It's got a nice built-in voltmeter there on this capacitor, which is quite nice. So we're going to test the new battery, first of all. Should be charged. So we're getting 12.8 on that, so it's nice and charged. Don't know if you can see that. Can we see it? So that's good, nice and fully charged. I'm going to use this battery to charge this capacitor to make sure this works. Now what we need is this little circuit there, comes with the capacitor. It's got a little resistor on there, and it stops the capacitor from sinking loads of current in one go. So we're going to use that. So these lights are going to tell us when it's charged. So the red light means it's charging, and the green light should light up when it's fully charged. And we should also see this voltmeter go up to about 12 volts as well. Obviously the lights are the other way around. Okay, I'm not going to charge it anymore, it's clearly working, it's doing alright. Now, the handy thing about having this voltmeter on here means it will discharge itself because it's got to power its own voltmeter there, that little circuit. So it's looking good. So you can see it goes on to low. If it gets below 10 volts, it goes to low, flashes a bit of a warning. We're going to leave it till it stops flashing before we do anything with it, because that means the charge is gone. Be careful though, the charge won't completely go. Even when that goes off, it will still have some charge in it, so still be careful. Looks like everything's working, so let's go and start the project. Okay, we're in the garage. We are with Maxwell. If you don't know, Maxwell is the name of this generator, obviously after the great man, James Clerk Maxwell. Apologies for the state of the garage. We just moved house and everything's a mess, and obviously the priority is to upgrade the bike generator and not sort the garage out. Why would it be anything else? So a quick look at what we're doing. Here's the old battery down here. This is coming out. That's kind of gone. You can see on there under 7 volts. It's shafted basically. That's a 12 volt battery. So that's coming out. I'm going to change this. So you see the cable here runs up the bike to the dashboard up there. It's a bit of a mess and it makes it difficult to get the bike on and off. So so that's coming off, and I'm going to route it along here. This switch is broken and it's kind of not big enough. It's all broken at the back, so we're going to take that off and put a new one on with more switches. And we're going to get our friendly capacitor in place. So that's what we're going to do. Let's crack on. Obviously, if you've not seen the original bike generator videos, check them out. I'll put the links in the description below. We've got an overview of this, how it works, how it's put together, how it evolved, and we've got a step-by-step video as to how to build one, and also one on the merits of AC generator versus DC generator. So check them out if you want a bit more information on it. Just worth mentioning, there's a lot of cable here. You don't really need all this. It's just I've used whatever I had hanging about at the time when I made the generator, because I like recycling bits and pieces, so I've just used whatever cable I had. I've actually got, for the new bit, I've got some 4-core, so I can run 2 switches from a single cable, whereas some of this is 3-core, some of it's 2-core, so there's 1 cable per switch, which is excessive really. Day 2 of operations. It got too dark, too cold last night, so it's just me today. Lost my camera crew. So I have to whack the camera down, I'm afraid. Alrighty, we are done. Wiring's finished, all sorted. Took us about 3 days in the end, just because I'm doing it around work and bits and pieces, so we're doing it in the dark, doing it with a head torch on, all got a bit ridiculous. It's now beautiful bright sunshine and snow, so we're doing this in between the snow. Welcome to April in the UK. Right, I'm going to take you through the wiring, show you what we've done, and then we're going to test it. We're going to see if it works. I'll tell you what we've done and why we've done it. Here we go. Right, we'll start at the front. We've got a new switch box on there. This section, this side is for the source, the battery and capacitor, and this side is for the DC load, and the AC, so the inverter, is now on a separate switch down there. I am going to label these switches up. Obviously they're a bit blank at the minute, but I'm just waiting for the labels. I've ordered some labels and they haven't arrived yet, but I know what they are. And we've also got a little voltmeter, so I've installed a voltmeter on there, so that when I'm on the bike and riding, we can see what the voltage is. Just a safety thing, really. If the voltage goes too high, it can cause a problem. So if something happens with the alternators, gubbins inside the regulator, and we get too much voltage out, there can be a problem. Or if something's going on with the capacitor, we can see what's going on. We can also see if the voltage gets too low, and we can turn the load off so nothing gets damaged. And it's just easier to see it there if it's on the dash. Okay, so I've taken all the wiring off the bike. So as it was before, things were attached to the bike, which meant it was a pain to actually get the bike off to do bike maintenance on the bike. So all the wiring now runs down this side and along the bottom there. So it's nice and tidy. It's all tidied up really, and the switch is now not broken. Oh, another thing. We've got the ignition switch on there, so that is now just a press to get the field coil activated on the alternator. So following through, we've got the battery set up there, new battery. That's gone in. Got a fuse on the battery there. Capacitor is now mounted there. And obviously this is the alternator, and this is a voltmeter and current meter. So we've got volts at the top, amps at the bottom. And we've got a master switch. So this master switch isolates the load, all of the load, the various DC sockets and the inverter, isolates it from any of the sources of power. So the sources of power are the battery, the capacitor and the alternator. Now this is just, I've switched this on and these are all switched off, so this is now switched on. So if we go back to the dash, So this switch there, this switches the battery into the circuit. This switch is a charging circuit for the capacitor, and this switches the capacitor in fully into the circuit. So I'll show you that at the back. On here on the capacitor, you can see there's a little circuit board attached there with a little resistor on it, and there's also a cable running off there. Now this goes into a block there, which that goes to the switch on the dash. What this means is we can charge the capacitor up slowly, either from the battery or from the alternator once we're riding, and that means it's not going to be a big current sink. This is only a 7 amp hour battery. If you just switch this capacitor directly onto the battery, it's going to try and pull a lot of charge from the battery very quickly. If you're peddling, if you're peddling and you're on the alternator, if you just switch this in, you're going to get a sudden resistance in the pedals. So that's why we've left that charging circuit on. If you were normally, this capacitor is intended for a car audio system. If you were using it for that purpose, you would only use this resistor once. You just charge it once and then you connect it up. Because we're charging up, discharging, charging up, discharging, it makes sense to leave this in. Okay, moment of truth. I'm going to switch on the switch to the load, which is on. That's not going to do anything at the minute because there's no power. And I'm going to switch in the battery. So that's this first switch there, switches in the battery into the circuit. So let's do that. And we should be reading on the voltmeter. Don't know if you can see that, but it does say 12.8 volts on there. So that's showing the battery's nice and charged. Might seem weird that a 12 volt battery is at 12.8 volts, but that's just because when you charge a 12 volt lead acid battery, you tend to do it at 14 to 14.4 volts because that's optimum for them, and that's what an alternator puts out. So back down at the back there, you can see that we've got the other voltmeter, and this has got a voltmeter and a current meter. So the volts are in red, current is in green. Now that's just a bogus reading. That's just some kind of electrical interference on the sensor there, because there's no current coming out of the alternator. So you see when I moved it, it changed the reading there. So once we're generating power through the alternator, that'll get a bit more accurate. Yeah. Okay, so that's showing the voltage on the battery. Now what we're going to do is switch in the capacitor through the resistance circuit, which will charge it slowly so it doesn't put too much of a strain on the battery. And that is the second switch there. Now we can see there, you probably can't see the little light there that shows it's charging, but you probably can see we've now got a reading on its little internal voltmeter on the capacitor, and this little blue light. So this comes on when it senses a change in voltage, and this blue, that's what the blue light indicates. So it's reading low at the minute, and that's just saying it's below 10 volts. So as that starts to charge from the battery, what we'll find is you'll start to get a volt reading at 10 volts shortly, and then it'll climb steadily, and it's just charging off the battery. So there we go, 10 volts, and that's going to be charging up. Now what we might find is the voltage on this voltmeter may start to go down a little bit, because this is taking power out of the battery in order to put it into the capacitor. So we can see this circuit's working, so I'm going to switch that off to avoid draining the battery too much, and we'll get pedaling. Okay, so ready to go. We need some power, as you'll know if you've watched the other videos. If you haven't watched the other videos, give them a watch, because I talk through how some of this works and all the rest of it. As you'll know, we need a bit of power to get the alternator turning. So we've got a couple of options. Now we've got the capacitor in the circuit, we've got a couple of options. One is just to run it from the battery, So what the battery does is it sends power into the field coil of the alternator, which just gets the alternator started. Then the alternator generates its own power after that. So we can do that, and that's what we're going to do just for simplicity today. The other option will be to charge up the capacitor with the battery, switch the battery out of the circuit, and then get the alternator started with the capacitor and just run it on the capacitor. And the brilliant thing about having this set up with the switches on the dashboard like that is we can choose whatever we want to do for different times. It's good to be able to switch the battery out of the circuit and run it on the capacitor, because if you keep the battery in the circuit all the time, it wears it quicker, especially if you're not drawing it off and charging it back up. If it's staying quite close to the top, all that constant high voltage at 14 volts, it wears the battery quicker. So with this now, we can switch it out and we can just have the capacitor in the circuit, and that's one of the really good things about having the capacitor there. So we need to switch the battery on to start with. Battery's on and we're reading a voltage. We're starting pedaling, alternator's up to speed, and what should happen when I press the ignition switch is we start generating power. And we'll see the volts go up to 14.4. There we go. Okay. Alright, so that's working. Ignition switch is working. What we're going to do now is we're going to start charging the capacitor. And again, we've got two options. Now we're powering the alternator, we could just switch it on in full without resistance. But if we do that, there's going to be a sudden resistance through your legs to pedal. It's quite hard. So we're going to charge it using the resistance circuit first, as we did off the battery. So we can see the capacitor charging up now nicely. We can also see the current. The current that we're taking out the alternator, about 0.9 amps now. All that's doing is topping up the battery. So some of that's going into the battery, and obviously some of that is now charging the capacitor. So that's where the current's coming from. So we're going to wait till that gets over 11 volts or so. And then I'm going to switch the capacitor in full, so that there's no resistance. So it's going up quite quickly. So we can see the capacitor is now reading 14.6 volts. What we need to do is get some load switched on, otherwise we get too much voltage. So we're running the fans. If you've seen the other videos, you'll know how all this works. We've got a power supply down there that will power a laptop, phones, etc. And these fans, these three fans there, are all plugged into it. So I can switch the battery out of the circuit now. And I'm going to switch on some more load. So I'm now charging some power packs which are on there. It's important to keep some load on it when you're pedaling, especially with the capacitor on, because you don't want the voltage to get too high. So we can see down there. So those power packs are charging up nicely. And at this point we can put whatever we want on. We could switch the inverter on, we could run some stuff through the AC side, power the amplifier and the speakers. The overview video has a full demo of doing that kind of thing. I'm not going to do that today because I'll be repeating what's already there. The good thing is all of this works. Okay, so to switch off, I'm going to switch the items out of the circuit and then stop pedaling. And what we'll see is the capacitor will gradually discharge, but if I put some load on it, it will rapidly discharge as it powers the fans, and then they stop once the voltage gets too low. So you can see there's still a bit of low voltage on the capacitor. I'm going to switch it back out of the circuit now, and that will just gradually discharge due to its own internal circuitry. It's a little voltmeter and stuff built into it. Alright, super cool, it all works, which is great. We've got some quite exciting, I'm squinting because the sun's really bright now. We've got some quite exciting projects coming up with the capacitor, which is why we needed it, so stay tuned for them. If you don't want to miss anything, please subscribe to the channel. We've got some pretty cool stuff coming up. Hit the subscribe, ring the little bell jobby, and give us a like if you like the video. Thanks for watching. Do look out for that wiring diagram, and look out for the next stuff coming up. See you soon.